Hello everyone, this is the first part of a two-part video on performing heritability analyses in the UK BioBank dataset using Solar-Eclipse imaging genetics software. We will first review required files, software, and data QC, then continue to a video example of running heritability on a single phenotype, before performing a full analysis on voxelized data in the second video. Now, before we start, you will need to have downloaded the most recent version of the Solar-Eclipse software from our Nitrix site, the UK BioBank data, and P-Link software. From the UK BioBank data, you'll need to extract the genetic files and use the P-Link commands to combine and filter chromosomal data into a single file. The easiest way to do this is with the merge list in P-Link. Be sure to add your minor allele frequencies and Hardy-Weinberg equilibrium thresholds. It is also easier to only include the participants who have the traits that you're investigating. So if you're only investigating a subset of participants, it's easier to reduce the size of your genetic data files, which reduces the time required to modify them. Once you have created your P-Link files, you'll then need to create an empirical pedigree using Solar. So we'll go ahead and load Solar, and normally you just need to use this last bit to launch Solar on your computer if you've installed it correctly. And once you launch it, you should get this summary of what Solar is, and you can begin. So we'll start with the command plink freq with a Q that will allow us to create the P-Link frequencies before we make our empirical pedigree. Once we have our P-Link frequency files, we then can use the GPU pedigree command in Solar, called GPU pedi from SNPs. And this is much faster than our previous pedi from SNPs version. So we input our UK BioBank P-Link files that we created from our chromosomal P-Link files. We label our output file, what we would like to call our pedigree, and then we have to include the frequency file, which we labeled UK BioBank freq, and we need to normalize it. The other options like thread size, batch size, SNP stride, and number of GPUs is all optional. Once you have your genetic data, you will also need to isolate the traits that you're investigating. And for this, we would like to have a list of IDs, so we made our trait IDs list. And as you can see here, we have the left and right volume IDs for the thalamus. And so we'd use a command such as UK BioBank convert to pull out the trait IDs that we have listed in order to get our thalamus volumes. We can open up our phenotype file that we just created. And get rid of all of the extras that we don't really want. And relabel these however we would like. You will also want to include any covariates in your phenotype file that you'll want to add to the analysis. In this case, I've added age and sex. That can also be found using the UK BioBank convert data commands. We also need to create a header that will include only the names of the columns that we are interested in, so just thalamus left, thalamus right. And it's really just going to be those column names, and then we change any commas into spaces. Now we load our pedigree using load ped, and remember we just created it and we called it ukbbped.csv, and we use a threshold of 0. After our pedigree is loaded, we reload our phenotype file now with our UKB norm phenotype file. See again, now we're missing age and sex because those values have been regressed out of our thalamus volumes. And when we're working with the UK BioBank, we have to do an additional step called create EVD. So first we're going to select a trait, and it really doesn't matter which trait you end up using, because once you create the EVD for a data set like UK BioBank, you can keep reusing those eigenvalue decomposition values and vectors. So we'll just use thalamus left. And then the command is create EVD data, and we're going to output as UKB EVD. Storing the eigenvalue and eigenvector decompositions for our trait of interest really reduces the amount of time needed to calculate FPHI further down in our analyses when we're doing UK BioBank. So once we have those values stored in our EVD file, we can use the Solar-FPHI command, which requires the EVD option, EVD data, and we labeled it UK BioBank EVD, and we can go ahead and run our single trait heritability analysis.